Now that we've calculated B1, the slope of the regression line, and B0, the y-intercept at 0 on the x-axis, we can use these two coefficients to calculate a predicted value for total charges. We'll do that in column H, and we'll label this y hat, which indicates that it will be the predicted value of total charges, or the predicted value of y. The first predicted value we will calculate will be the predicted value for 3 days of stay in cell B2. So that will be equal to the coefficient, which we'll fix with an F4, times the length of stay plus the second coefficient, or the intercept. And again, that's fixed with an F4. When we hit enter, we get 3474, and if we drag that down to the last entry, we now have the predicted values for y for all of the lengths of stay in the data set. Now that we have the predicted value of y, we can calculate 3 sums of squares. We can calculate the sums of squares total. That is the squared difference between each value of y and the mean of y. We can calculate the sums of squares due to regression, which will be the squared difference between the predicted values of y and the mean of y. And we can calculate the sums of squares due to error, which will be the squared difference between each of the actual values of y and the predicted values of y. So we'll begin with the total sums of squares, which is simply the sum of squares of y minus y bar, which we already have. And when we hit enter, we see that the total sums of squares is approximately 78 million. In order to calculate the sums of squares due to regression, we need the squared difference between each of the values of y hat and the mean. And we'll put that difference right here. This will be y hat minus y bar. So for the first observation, it will be equal the predicted value of y minus the mean of y. We'll fix the mean with an F4, and we will copy this down with a double left click on the lower right hand corner. Now the sums of squares due to regression is again equal SUM SQ of this column. In other words, we have squared each value in this column and added them together, and the value we get is approximately 61 million. Now, in order to get the sums of squares error, we need the difference between each actual value of y and the predicted values of y. And in order to show that, we'll move to the right and put the difference between the actual values and the predicted values here. So this will be y minus y hat. The first value will be equal to the actual value of y minus the predicted value of y. And again, we will double left click the lower right hand corner of that box to copy it all the way down. And here are the error values. So for the sums of squares due to error, we will have equal SUM SQ, and we will select the error terms and then an enter, and we see that the sums of squares due to error is approximately 17 million.